They have been exploring the vast expanses of space for almost 50 years and providing us with groundbreaking insights into previously unexplored areas of the cosmos. But although the venerable Voyager probes are known to have already passed the boundaries of the solar system, unique findings from interstellar space are unfortunately not the only thing arriving at Earth stations. Quite the contrary. Some time ago, Voyager 1 suddenly began sending inexplicable chaotic data back to Earth, causing great excitement among NASA experts. The signals were so mysterious that those responsible described them as abnormal. But what really happened to Voyager 1 back then? Did the flying old-timer make a bizarre discovery that caused its instruments to go haywire? Or do we have to admit that even the most durable technology eventually gives up the ghost? Stay tuned until the end and see for yourself what was really behind this sensational incident. It all started with a daring idea. While the James Webb telescopes of our time are peering deeper than ever into the oldest mysteries of the cosmos, we must not forget that things were a little different in the 1960s. In fact, a flight to the outer solar system was considered virtually impossible at the time. And for the simple reason that Jupiter, Saturn, and the other planets are so far away from us that a research probe would have needed more fuel for its journey than a rocket could lift off with at all. The idea of studying the 4 outer representatives of our planetary system at close range was therefore tantamount to cosmic utopia until a man named Gary Flandreau came on the scene. Tasked with finding a way to shorten and speed up such a mission, the doctoral student in his small office at the Jet Propulsion Laboratory in Pasadena remembered an astonishing phenomenon that had already been recorded during the discovery of Neptune whenever Uranus passes its outer neighbor. It briefly speeds up and then slows down again. Researchers had already observed a similar principle with comets. So, wouldn't it be possible for space probes to take advantage of this planetary gravitational swing? Furrow pondered this question intensively and came to the conclusion that not only was it possible, but that a probe could even gain momentum through multiple close flybys and planetary orbits and visit all the outer planets in one go. This would reduce the flight time by almost 20 years, but that was only theory. In practice, it would also require a favorable planetary constellation to make this project possible. But as luck would have it, Flandreau realized that in the mid-1980s, all 4 gas planets and Pluto would actually be on the same side of the Sun and quite close to each other. And that was putting it mildly. After all, such a constellation only occurs once every 175 years. The birth of the Voyager probes. With time ticking away, those responsible began to develop a mission concept. If everything had gone according to plan, not just 2, but 4 probes would have been launched into space in 1977 to investigate the outer planets, which were still largely unexplored at the time. However, at a cost of $900 million, this was a little too expensive for the U.S. government. After all, the space race had already been won with a manned moon landing, and space travel was no longer a priority in the budget. And so it came to pass that the program was reduced to 2 probes and the flight plan was cut back to the bare essentials. Only Jupiter, Saturn, and its moon Titan were to be targeted. The onward flight to Neptune and Uranus was initially put on hold. Of course, it's impossible to say today how the government and NASA management would have reacted if someone had told them that the Voyager probes would one day venture into interstellar space. What is certain, however, is that the spacecraft had to be equipped for their long stay in space. Designed based on the Mariner probes, Voyager 1 and 2 were supposed to last up to 10 years in space, which at the time was considered an eternity to protect the spacecraft from Jupiter's extreme radiation. All sensitive parts were fitted with a special protective shield. At the same time, all essential systems such as onboard computers, data storage devices, and radio receivers and transmitters were installed in duplicate using technology that seems almost laughable by today's standards. Because let's face it, the onboard computer of the Voyager probes has hardly more power than the automatic door opener of a modern car. In figures, this means that the onboard computers can process 80,000 instructions per second. And even if you have an old smartphone gathering dust on your shelf, it has a processor that can handle more than 15 billion instructions per second. But what our old cell phones can't do is travel into the vastness of space and revolutionize our astronomical knowledge. What the Voyager probes discovered on August 20, 1977, the moment finally arrived. But bizarrely, it was not Voyager 1, but Voyager 2 that first launched from Cape Canaveral Spaceport in Florida. Its identical twin sister followed on September 5. However, as it had a slightly shorter flight path to Jupiter and Saturn, it was still expected to arrive earlier and thus live up to the 1 in its name. And so, It came to pass that Voyager 1 entered the Jupiter system in March 1979 and provided us with spectacular images of the planetary colossus. These included not only the stormy atmosphere, but also the first lightning bolts ever seen on a foreign planet. But even more astonishing was the case of Jupiter's innermost moon, Io. Previously thought to be a dead ice world, the Voyager images revealed an unexpectedly colorful and dynamic celestial body. And for good reason. Subsequent analysis showed that Io is a hyperactive volcanic moon. The flybys of the moon Europa were just as spectacular. Images of its icy surface and data on its density and heat distribution provided the first indications that it could be hiding an ocean of liquid water. And indeed, Europa is still considered a hot candidate when it comes to the question of extraterrestrial life. The detour to Titan, just 6,500 kilometers away, revealed that it has a nitrogen atmosphere mixed with hydrocarbons and that the methane and ethane on its surface are probably liquid. However, the word probably has now become certainty because Titan is actually adorned with methane lakes and rivers. Voyager 2 then provided us with breathtaking insights into the Saturn system. And while we were now enriched with fascinating images of the rings and several moons, something happened that in retrospect seems almost like an ominous harbinger. A serious technical problem arose that jeopardized the entire mission. After Voyager 2 had gained momentum at Saturn for its onward journey to Uranus and Neptune, its camera suddenly jammed. Fortunately, the blockage was eventually cleared. But exactly what happened back then remains a mystery. The fact that Voyager 2 arrived at Uranus in January 1986, however, is an open secret. Here, the probe not only discovered 11 previously unknown moons, but also revealed that the supposed gas giant is actually more than an ice giant. Beneath the planet's gas envelope is a thick layer of water ice. But that's not all. With its 4 poles and dented corkscrew shape, Uranus's magnetic field can certainly be described as unusual. The inexplicable data from Voyager 1, the extremely rugged surface of Uranus's moon Miranda, also caused astonishment among experts because we don't actually know of any other celestial body that has such bizarre landscape features. What this mosaic-like surface is all about remains unclear. All the clearer, however, is the image we have had of Neptune since August 1989. In true Uranus style, it also turned out to be an ice giant with a similarly bizarre magnetic field. What followed was a journey into completely unknown worlds. Well, at least for Voyager 2, because Voyager 1 had already set course for the outer regions of the solar system in 1980. On August 25, 2012, it reached interstellar space, becoming the first man-made object to cross this boundary. Voyager 2 followed in November 2018. Together, the probes showed that this area is much more complex and dynamic than previously thought. Basically, the space far away from the stars is not simply empty, but filled with the interstellar medium. This medium consists of gas, dust, and cosmic radiation, and it has a much greater influence on our heliosphere, the protective bubble surrounding the Sun, than experts had previously thought. For example, the interstellar medium exerts up to 10 times more pressure on the heliosphere, and there are more interactions between the two zones. In addition, on this side of the helipause, or in other words, at the outer boundary of the heliosphere, there is an extensive magnetic barrier that acts as an additional shield against cosmic radiation. The information provided by the Voyager probes about interstellar space is therefore both revealing and unique. Unfortunately, however, an incident occurred 3 years ago that initially left scientists completely baffled. At that time, Voyager 1 suddenly began sending strangely chaotic telemetry data that simply did not make sense. The situation was made even more confusing by the fact that the probe was otherwise functioning as usual, and the main antenna was still pointed toward Earth. In the end, it took several weeks before scientists got to the bottom of the confusing data chaos. Contrary to some astonishing internet theories, the probe was not hijacked by an alien civilization. Instead, the attitude control system had mistakenly attempted to send the telemetry data to us via an onboard computer that had long been defective. As a result, the Voyager data arrived as meaningless junk data. However, once the source of the error had been discovered, NASA used the radio antennas of the Deep Space Network to instruct the system to transmit the data to the correct, still intact onboard computer in the future. This was successful and Voyager 1 was able to continue its mission. However, how long this will continue to be the case is another matter entirely, as the pair of probes are now showing signs of serious weakness. In order to maximize the mission's lifespan, NASA has been following a strict power-saving plan for some time, which involves switching off more and more instruments on board. Despite all this, the day of farewell is inevitably drawing nearer, and the longest-running success story in space travel is expected to come to an end in the 2030s. And before our video comes to an end, don't forget to click on the subscribe button. Simply press the thumbs up and click subscribe to never miss another post from us. We'll see you soon.